Hi there, I'm Andrew Brown. Welcome to Real-Time Music and Sound with Pure Data. In this video we're going to be looking again at the live coding toolkit for Pure Data. This is one of a series in the live coding toolkit introductions. You'll need to download the live coding toolkit if you want to follow along with this video. It's available on GitHub. And when you do download it, you'll need to make sure you go to the paths in PD, in the preferences, and make sure that you add the folder where the live coding toolkit is to PD's paths so it can see it. The other thing which we're looking at today is some graphics on top of the PD patch. I'm going to be using, in this case, the Hydra live coding visuals environment you can see on my screen. Hydra is written by Olivia Jack, so thanks very much to her for programming that. In addition, we're going to be using some MIDI extensions to Hydra, the Hydra MIDI by Arno Schliff, in order to communicate via MIDI between PD and Hydra. And I'm also making a bit of use of a visual script by Resnotor. The script's called Disintegration, and you can see it wavering on my screen at the moment. What will happen is that the PD window in which I'm typing will be superimposed on top of these graphics, and doing so will possibly make it a little bit pixelated, but hopefully the overall result is good. So that's by way of quite a bit of a long introduction, but the reason we're doing this is one of the mantras of live coding is show us your screens, and when we do show both our PD patches, it's kind of useful to have some interesting graphics just to keep everything visually interesting as well as sonically interesting. So today we're going to be doing some sort of sample-based music with a little bit of synth bass. We're going to make a fair bit of use of two of the core functions in the live coding toolkit, the periodic function and the cycle function. So let's get started. So in order to do this, I'm going to, as we often do with the live coding toolkit, start with a tempo object just to keep everything synced together. This will provide our kind of metronome pulse as we go. I'm going to want to grab every sort of eighth tick in that tempo for the minute, just to sort of get a starting sort of downbeat. So I'm going to do modulo 8 to do that. I'm going to select the downbeat, and when I do, I'm going to send a 0 message. Send that to a trigger, which goes out to a bang, and then that's going to play the poly sample object from the live coding toolkit, and we're going to use a recording called low-perc.wave. I have used this in a previous video, this sample. It's a series of 10 percussion hits evenly spaced throughout the audio file. That allows me to chop up the audio file in even segments and get each of those samples one by one. I'm going to go out to again, set it a little bit high so we get a little bit of mild distortion, and then to the live coding toolkit's out. Those last couple of objects are all stereo, so I need to connect up the other channel. And I also need to specify the beginning and the end location of the samples. By default it will start at the beginning, which is fine some of the time, but not all of the time. So I'm going to do that by getting a value, making sure that it's rounded and kept within constraints that I know I can use. Divide it by 10, because I've got 10 samples in my audio file. That will determine for me the beginning location. That will come from this value here of my sample. To determine the end location, I'm going to take the beginning and add almost 1 to it, so that it goes from like 1/10 to 2/10 of the way through the audio file, for example. Okay, so if I start this, so it's currently playing the first sound file in my low perc wave. So now we want to make it so that it will play a few more of those samples. So I'm going to first of all take modulo 2 so that we get every second counter triggering. I'll check when that's 0 for doing that, and go out to a gate, but I don't want that to be on that part of the gate. I want it to be the opening and closing of the gate there. The gate's actually going to take its values from the tempo, and so that's all good. That will get its values out of here whenever we're not playing the downbeat, and we need to put in our first periodic object. It's going to be a 16-note oscillation with a center of 6 and a deviation of 6. So that will be triggered from there. And when that goes, we might pull this down a little bit. That will then go in there as an alternate trigger to that downbeat. Okay, so that's got us going. I'm going to vary the loudness a little bit. Just turn that down for a second. So just vary the volume at random. Just to give us a little bit more variety. And so that we don't just get the same pattern all the time, I'm going to vary the periodic function with a random value as well. The rand function, if you recall, in the live coding toolkit, has a center frequency and then a deviation. The middle outlet is a Gaussian, which is what I'm going to use this time. Okay, so there we've got a sort of a reasonably stable rhythm, but with little bits of variation in it from time to time, which is great. We just get a bit more variation in the rhythm, because the rhythm is pretty static at the moment. So use a random value to change that. Offset it because I want values that don't include 0. And that's going to change the modulo amount there. Okay, so there's our first rhythmic part. We're going to make a very similar rhythmic part. So I'm going to copy quite a lot of this and paste it into a second rhythmic part. First thing I'm going to do is change the sound file that it uses, using another similar organized wave file but with different samples in it. Most of the other things are going to be quite similar. We use a slightly different periodic wave value. I'm going to filter out some of the parts so we don't just hear everything all the time. And if I connect that up, that will start that going, but we need to connect it to the audio out. In fact, probably I will do the audio first. connect it up. And similarly to before, we'll use some random values to mix that up a little bit. Okay, so now that we've got a bit of a drum pattern going, we might give some attention to our Hydra visual patch. As I mentioned, we do have the ability to send control messages out. So I've got some controllers that control the RGB values. You can see it's all grey at the moment. So if I just randomly change one of those color values. Maybe if we do that every time we get a downbeat. Probably should make sure we bang it. No, actually, that's alright. Take it from there. Okay, so on the screen you can see that we're changing colour now. This is affecting the red channel of the RGB. So we can do a similar thing to that for some of the other colours. Where's a good place to take that? Let's take it from this one. Alright, so we've got some variety in our colour happening now. We'll fix up a few other things in it maybe later on. No, let's do a little bit more on that while we're on the Hydra stuff. Okay, so the control out, there's a variation in the pattern in the background you'll see, which is controlled by some noise. So I can vary that noise amount there. So let's do this. Okay, so if I divide that output by 12, should get me to the right range. Drastic, so maybe let's do that a little less drastically. Yeah, enough with the graphics. So let's turn our attention back to the music, and we'll add a bit of a bass line. I'll do this by using a random sequence to generate our bass line. That random sequence requires a bang to get going, and we'll send it to a cycle object. Just give it some default values. Okay, so that will generate a list into the cycle. So then we just need to process that. Just gate it to reduce the number of notes, quantize the pitch, transpose, which I might use later. We'll send that out to the inbuilt synth object in the live coding toolkit. Okay, spell quantizing correctly. Okay, so we just make sure we've got some volume control over our bass, and then send that to our main output. Alright, so that's started, so we just need to connect it to the tempo to keep it going. Okay, so a few things I want to do to that bass. One is I might just modulate its cutoff frequency, fairly common thing to do. We'll use a periodic function to do that. That will generate values of 32 note sine wave kind of oscillation centered around 80. So that's kind of MIDI pitch like. We use MIDI frequency to give us frequency values, and then control the synth's cutoff frequency with that. Okay, so I want the bass line to keep changing, so modulo 32, select 0 whenever we get to the downbeat. For that, we do that, we will trigger a regeneration of the bass line. Any mono, the bass line, that's a bit of a pain. That's better. Apologies for that. Alright, so there's our drum and bass going. We can go one step further than this and create another synthesized part. Move this all out here, give yourself some space. It's not so very tight at the moment. But if I grab all this, create a second synthesized part, and we'll do a higher frequency synthesized part this time. So we'll have pitches up a little higher and a little wider in the range. Otherwise, most of those things can remain the same. We might put a bit of an echo on there. Some values for timing and amount. Okay, so then that can go there. The other channel over to generate a sequence for that higher part and then trigger it with the tempo. And adjust its frequency cutoff as well. Time for us to start winding this down. Got everything built at the moment. To do that, I'm going to use a value to change all of the gate amounts simultaneously. So that one. Where else have we got these? This one there. Use this to change the values that are being sent to other things as well, but that's what it does for now. So we've got our music playing and we're going to reduce the overall density of all of the parts simultaneously as a way of generating an ending. And we're done. Okay, so that was really interesting to be able to combine PD and Hydra and do some graphics as well as some sound for our live coding, showing our screens. So I hope you enjoyed that and have fun implementing some of those things, and I look forward to seeing you in another video.